Likewise, we have seen IGMP, Gateway to Host. Now we have something called multicast route. So in multicast routing, topology will be like this. We have a server, multicast server. Now it's not connected to a lot of routers now. When you are like indirectly connected to my client is sitting here. So here you can run IGMP. But then to reach here to here, we need something called multicast routing. Like we have dynamic routing, unicast routing protocol, we have same thing, we have multicast routing. Now, before I'll start your multicast routing, I'll just let you know, in your syllabus you have two, before we used to have a lot of routing table, routing protocol, dynamic routing protocol like DVMRP, distance vector multicast routing protocol. We have before we have one MOSP multicast open shortest path first, like type 6 LSAs are like multicast LSAs. Just one second. Multicast opens shortest path. Six LSA. Then you have the protocol which is going to learn is called PIM dense mode, PIM sparse mode. Full form is protocol independent multicast. Multicast dense mode. Protocol independent multicast sparse mode. One more we had was CDT, core based. In your syllabus, you have to learn these two. PIM dense, PIM sparse. The other protocol, see the difference is here, this is why we are using PIM, why we are not using PIM, because see, multicast will going to create their own database. These protocols, they have their own database, their own calculation. But PIM dense and PIM sparse, when I will going to show you practically, it depends on, first of all, we have to run OSPF or EIGRB, any protocol. On top of that, you have run multicasting. So it depends on multicast routing or unicast routing table. Whatever is your routing table, it is going to follow that. So it is taking help of your routing table. It won't create its own separate database. It has a multicast routing that also some timer is there for 3 minutes will be there. So like CPU and memory will be saved here in PIM. So OSPF, like if running in the backend, that will create its own unicast routing table. But multicast won't create any nothing called their own database if you are using PIM dense and PIM sparse mode. If you are using these other modes, they have their own database. Okay, but in our syllabus, everywhere we use like PIM dense and sparse mode. Now, few small differences I'll tell you. Like where to use dense mode, where to use sparse mode. See, just an idea. If suppose in your environment you have like 1000 PC, out of that 800 PC required multicasting, just a recommendation. Use dense mode. Of 1000 PC, only 10 PC required multicast. Use sparse mode. Okay, now I'll tell you there are two different ways in multicasting you will learn. Okay, which is eventually will become dense and sparse mode. Then I will discuss on that. This is where you have a multicast server. Okay, so we have a concept of like we have a user there. These are user connected. Connected. First way is called implicit join, or we call it SPT, shortest path tree. So it's actually a concept where what actually multicast server will flood the multicast stream. Flood, flood. Okay, flooded everywhere. Okay, suppose this side no one is using, no one is listening to your particular stream. Okay, so what this guy will do? He will send a prune message. I am not using anything. Next time, do not send me any flood on this particular site. Okay, if they don't want, they can send prune message. Or I will say in other word, if you are not listening to a particular stream, come no one, no single user in this particular subnet is listening to a particular multicast stream. Then it will send a group. Detail I'll tell you, just get an idea. It will send a group. This way is called implicit join. Here we have a concept of S comma G. S means when a message will come, multicast frame will come. Oh, sorry, that multicast frame will come. what is your source and what is your group, meaning server IP and on which stream, like on which IP, like I'm sending on this particular multicast IP, and it will take shortest path. Okay, this is one way which you will going to learn, and which is called again, remember that implicit join or shortest path tree. One more is called explicit join and shared tree. I'll explain it. Explicit join and shared tree. Now it works like kind of we have seen OSPF where we have a DR BDR concept. So here we create one rendezvous point. Okay, RP. Here concept is when flood will come. First of all, everyone will going to try to join themselves to RP. They'll send a join message initially. This guy will also join. Okay, so now here data, but data will be flooded. Data will go to RP first. Whenever any flood will come to RP, and then RP will going to flood it to everyone. Okay, so data will go to RP. To other via shared path. Okay, through RP, he is going to send it to the other. So kind of like DR, BDR, or we can say like in route reflector, first we go to the route reflector server update or data packet, and then it will go to the client. So here we have to choose one guy called rendezvous point. Everyone will going to join to this guy. Okay, when they will join, what they are joining, that we are listening to this particular group, listening to this. So what he will do, first he will flood, and he knows that on my what link, what all are listening. Accordingly, he will going to flood. That detailing will going to learn. That is actually I am pointing towards this concept are similar to. So before what I have shown you was implicit. That is similar to dense mode, and this is what shared mode will work like. Okay, but all your protocols are quite similar. Here again, concept is it is star comma G. Okay, so when they will join these guys, okay, they cannot use S comma G because they do not know the source, they know the group. So they are saying that source could be anything. We want to join this group. So I'll show you practically how it works. Always remember implicit join is S comma G, explicit join is star comma G. So detailing, this is what we have to learn, all the details about Swim, dense and sparse. This is all about your in your multicasting we have to learn different variants on this particular. Okay, so I'll give you one list which will be for your understanding. I'll put all the protocol DBMRP, MOSP, PIM dense mode, PIM sparse mode, CBT. Okay, now we have seen dense mode concept. We understood that how sparse mode works with the random point. We have property called implicit join, which is called flood and prune. We have explicit join, RP concept. We have SPT, shortest path tree, and we have a shared tree concept. Which protocol support what all functionalities? That just I'll just put it in mark. Now DBMRP will work like a dense mode. If you are working like a dense mode, it cannot work like a sparse mode. Then if you are working like a dense mode, it should have a property of implicit join, cut, and prune. It should not have a property of random point. It should work with SPT, not with a shared. Next, MOSP. It supports again dense mode concept. It does not support sparse mode. It does not support flood and prune because it's an OSPF. It supports rendezvous point of concept like a TRBDR, and it supports SPT shortest path tree, but it does not support shared tree. Okay. If I'll jump to the other side, PIM dense. It's easy to support dense mode. It does not support sparse mode, implicit join. It does not support explicit RP. It supports SPT. It does not support shared. Okay, and then if I talk about PIM sparse mode, no dense mode, only sparse mode, no implicit join, only explicit join, no SPT, only shared. If I will say CBT, CBT means no dense mode. It's similar to your sparse mode. No implicit join, only explicit join, no SPT, only shared tree concept. Okay, overall, they are using these properties. Okay, so I'll explain you how your multicast routing table is created. One small data flow I'll tell you, then we can start off with the dense mode after that. This is your multicast server. And here you connect it to a router. So what happen is when a multicast stream will come, which is S comma G, meaning suppose server IP is 10.1.1 and I'm sending stream on 10 to the dot 29.1.1.1. Okay, when it will hit here on this router, now multicast routing is enabled here. Now the first thing this router will check, always remember, is called RPF. The same concept what URPF is, reverse path forwarding. But in multicasting it is called RPF. In your routing concept it is called URPF. So it is for to detect the loop, whether the loop is generated or not, and to find out the shortest path. Okay, it will check your source, that you are coming from the right source interface or not. Same concept what URPF concept. Okay, so where actually it will check whether you're coming from the right source or not. It will check your source IP and that interface in the that lookup will be performed. Look in a unicast routing table, but OSPF or EIGRP form. So it will be written that okay, 10.1.1.1 is a 0/24 is reachable via F0/0, meaning it is coming on right interface. So we need to check whether the incoming interface is correct or not. That is what concept of URPF also, same concept, nothing. So RPF we use to find out best path and to avoid loop. Okay, once this RPF check is through, again I will explain you all these things again, we will see practically also. These are steps how your multicast routing table will be formed when you enable PIM. Okay, I'll just put it across when you enable PIM in your network. First is RPF check perform, whether you are coming on the same correct interface or not. Okay. Second thing, it will going to create dynamically something called multicast routing table. Okay. So that will, I'll just make a note. Dynamically, it doesn't have their own database in PIM. It is taking the help of unicast routing table. First it performed RPF and then dynamically form mroute. So idle time for this routing table, which is multicast routing table, is 3 minutes. Meaning idle time, if it is 3 minutes you won't use this, I will show you it will be removed automatically. Idle time, it will remove automatically. Okay, so like if you will check the routing table, show IPM route, it will be written like this: incoming interface F0/0, where I have confirmed my RPF neighbor directly connected. Okay, now outgoing. Now what it will going to do, we need to check. We will going to send flood on both the sides. First of all, PIM should be enabled. Okay, basic functionalities, PIM should be enabled. They should become PIM neighbor. Okay, so for outgoing interface, it will write suppose S0/0, S1/0. PIM enable interface. And see, on this particular interface, flood will send a flood. Okay, again timer for that is also 3 minutes. Okay, complete procedure I will tell you how it works. Otherwise, it will remove. And here, suppose you are sending a flood, and this guy is also sending flood to him. See, this is a situation where loop can occur. You are sending flood to each other. So I will check the source of a flood. Source will be same. Okay, and see, it is saying that source is, see, on the routing table, I am saying that 10 is reachable on this interface. 10 is reachable on this interface. So when it will go to this, but flood will go here, it will check the source IP. He will say that source IP should come from here. It is coming from here. So RPF will be performed. So here packet will be dropped. Okay, so it will drop. Here it will check the update, exit interface is S1/0 via like RPF. So what it will do, it will avoid the loop. Simple concept. You just need to recall your URPF concept. URPF is saying that 10 is reachable via S1/0 and here 10 is reachable via S0/0. So what happens is when flood will go here, flood will go with the source IP of 10.1.1. This guy will check when it will check the RPF performed. Okay, because whenever you receive multicast routing, that flood, I will check the RPF. He will check source IP should come from this side. Why it is coming from this side? So drop. Same way, flood will be coming from this side. Again, he's saying that it should come on S1/0. Why it is coming on this interface? Drop. So RPF play a major role in loop avoidance. Okay, so like a lot of things will happen here also. Prune message will come, which I will explain you. Just get an idea when flood will reach. Right now, just get an idea like this. RPF will be performed. Routing table will be created. 3-minute idle time, and then see here we have to become a PIM neighbor. Then only flood will go out. Or depend if it will send a prune. Here it will return like this. S0/0 is like in a forwarding state, suppose, and S1/0 is in a prune state. Different conditions I will show you practically. So practically you will learn more. Right now, just an idea. Okay. So now we can start off with your PIM dense mode, which is what we are like this overview I have seen, you have seen, and its implicit concept, SPT, flood and prune concept. Okay, then after that, this will be easy. PIM dense mode, not much utilized in the production. PIM sparse mode is the important, but still we have to learn. You should know how PIM dense will work. It is very easy concept. Okay, so we'll go with the introduction today. In multicasting, in PIM, we have two flavors as I have explaining you, dense mode, sparse mode. Okay, as I have told you, first of all packet level we're going to see, but you should have an idea. PIM, when they will become neighbor, see they are sending something called hello packet. Timer is 30 seconds. After every 30 seconds percent, and that timer is 3.5 time based on the hello timer is your dead time. Okay, in PIM we have like two versions, version 1, version 2. Now, version 1 of PIM was using IGMP protocol 2, and its multicast address is 0.0.2. But in version 2 they changed the concept. They have their own protocol number 103, and they have their own multicast address also. So we are using PIM version 2. By default they are using. Okay, so other functionality of PIM dense mode use again the property what I have explained you called implicit join. Flood and prune, shortest path. Okay, now what messages we're going to learn on PIM dense mode message type. Okay, we have like we're going to learn about hello packet. We're going to learn about join or prune message. We're going to see about graft message. We have something called assert message. Okay, before I'll start here, this protocol independent uses unicast route table for RPF check. Okay, again, no separate multicast properties we need to understand about PIM. No separate multicast routing table. Sorry, multicast routing protocol. Like DVMRP. Okay, it's a separate protocol and it has its own database. That is what I'm pointing towards. PIMDEMs use simple concept of flood and prune behavior. Easy. When I will show you the conditions, it will be very, very easy for you. Okay, which has 3 minutes of idle time. I'll explain you what I'm pointing. And it's a classless, but as long as classless unicast routing is in use. As long as classless unicast routing is in use. Okay, so we have different behaviors. Just a second. We're going to discuss and then practically we'll see where all your IGMP and everything will be covered. Okay, so first we will going to see like how things work. Okay, and that same concept, like when you will flood, how rune will come. Okay, we will see here hello messages. Okay, so that join and rune concept will going to see. Second type, I'm going to explain you there's a concept of join or rune override concept. Important, good for interview, but again real time little bit they won't use that much. But you can see right now in data center, most of the concept they use multicasting and they're using sparsely. Still, we need to learn properly dense mode. Third variant, I will tell you about a good concept called graph concept. Graph technology. You should know this also. And the fourth is concept called assert message. This is the same concept like yesterday when I was teaching you IGMP and who will become the querier when you have two routers. Here also you have a two routers, okay, who will send a flood. So first, step by step, we're going to see the theory. I'll show you the topology also. Okay, so from first we're going to discuss this, second this, third this, fourth this. How actually I will going to let me show. Multicast film dense mode. See this? So we'll take pieces. First point where I put the first piece where we'll see hello packet flood and boom. Here we can in this section I can show you here I can show you the flood and boom concept. A lot of CPU utilization will be gone because too much packet will go back and forth. I'll show you that here we have to open debug. Wireshark won't help us much. Okay, here in this way we have to use see that room override concept. Okay, and on this section we're going to see the assert message. Everything we will going to cover in the single topology. Okay. But again, here also same thing like graph message I will show you. So this is your PIM dense mode. Okay. First, what we're going to do is tomorrow. First, we're going to understand all these four modes, and the next day we're going to do the practical, and then immediately we'll start PIM fast. Okay. So today a lot of students are not there. We continue.